Hello students, welcome to Sauras's classes. The topic of this video is matrix. So let us start with the definition of matrix. Matrix is defined as a set of mn numbers, real or imaginary, that are arranged in a form of a rectangular array of m rows and n columns. And it is called m by n matrix. An m by n matrix is usually written as A is equals to A11, A12, so on till A1n, like this. Now in a compact form, the matrix is represented as A is equals to Aij m cross n, or A is equals to Aij. These numbers A11, A12 and so on, they are known as elements of matrix. An element Aij belongs to ith row and jth column. And it is called I, jth element of matrix, I, jth element of matrix A Ij. Now, thus, for an element Aij, the first subscript will represent its row, and second subscript will represent its column. Next is row matrix. Row matrix is a matrix that has only one row. And it is called row matrix or row vector. Similarly, column matrix is a matrix that has only one column and is called column matrix or column vector. Next is a square matrix. A square matrix of order n is a matrix that has n rows and n columns. Square matrix is a matrix that has equal number of rows and columns, and its order n determines the number of rows and columns. So square matrix is denoted as A is equals to Aij n cross n. Next is diagonal matrix. A square matrix represented as A is equals to Aij n by n is called a diagonal matrix if all the elements is called a diagonal matrix if all the elements except those leading in the diagonals are 0. That is, Aij is equals to 0 for all I not equals to j, where both I and j runs from 1, 2, so on till n. Now, a diagonal matrix of order n will have d1, d2, so on till dn diagonal elements and is represented by diag d1, d2, so on till dn. A matrix denoted by A is equals to Aij n cross n. A square matrix Aij n by n is called an identity matrix or unit matrix if Aij is equals to 0 for all I not equals to j and Aii is equals to 1 for all I, where I, j is equals to 1, 2, so on till n. So this is the identity matrix. In other words, identity matrix is a square matrix each of whose diagonal elements is equals to 1 and non-diagonal elements is equals to 0. Like this, 1, 1, so on till 1. Each of the non-diagonal elements are 0. And diagonal elements are 1. And this identity matrix of order n is denoted by In. Next is null matrix, which is a matrix whose all elements are 0. That is, for A, Ij, n cross m, Aij is equals to 0 for all I, j. Next is upper triangular matrix, a square matrix denoted by n by n, Aij n by n, is called an upper triangular matrix if Aij is equals to 0 for all I greater than j. This is a upper triangular matrix, and as we can see here, all the elements below the main diagonals are 0. Next is lower triangular matrix, a square matrix Aij of order n. A square matrix of order n is called lower triangular matrix if Aij is equals to 0 for all I less or smaller than j. This is a lower triangular matrix, and as we can see, all the elements above the main diagonals are 0. A triangular matrix of order n is called strictly triangular. It is called strictly triangular if Aii is equals to 0 for all I is equals to 1, 2, so on till n. So if the diagonal elements are also 0, then the triangular matrix will be called strictly triangular matrix. So these are the different types of matrices. Next we will study trace of matrix. Let A be a square matrix of order n, then sum of all the diagonal elements of A is called trace of A, and it is denoted by TRA. So this is equals to summation I is equals to 1 to n AII, that is sum of all the diagonals of A. Next is equality of matrices. Two matrices denoted by A is equals to Aij m by n and B is equals to Bij r by s are equal if number 1 m is equals to r, that is both the matrices have same number of rows. Second, n is equals to s, that is both the matrices have same number of columns. And third is Aij is equals to Bij for all I equals to 1, 2, so on till m, and j which is equals to 1, 2, so on till n. If two matrices are equal, then we write A is equals to B, otherwise we write A is not equals to B.